So I'm just going to create a new project, and like I said, we're going to walk through some loops. Very straightforward stuff. Example, while loops. Okay, so I'm going to create a source class here, and I'm going to call it while loop example. And there's a shortcut, by the way, for typing out the static public main void. I believe it's public static void main tab. Yep, there it is. Did y'all see that? It's magic. PSVM tab. Yeah, makes life easier. All right, this is a way we can do it in IntelliJ. Give me 1 second here. All right, so we're going to just create some sample while loops. A while loop is going to evaluate what's in the parenthesis for true or false. And it will run this loop as long as the value in the parenthesis evaluates to true. Now, this statement here will run forever. Do you know why? Because it never evaluates the false, right? I've put the actual value true in there. To give you an example, I'll run it, and this is called an infinite loop. This is always bad to do, hence why I'm going to do it. And this will run forever. It won't stop. The only way to kill it is either it kills your computer has to shut down and lose memory, or you use a Control-C to exit the program. Or in IntelliJ, you can click that little box there to kill it. This is an indefinite loop. Now, let's make the loop something more interesting. So we're going to say int equals 0. We'll call it int I for an index. And we're going to say while I is less than 10. Now, again, if I run this program at this point, will I ever be less than 10? Yes. So it should not even run, right? We should not get anything. No, it's indefinite because I is always less than 10. So it'll always run until this statement here is false. To validate that, we'll just type in false. Let me spell it right. All right. And IntelliJ is going to alert me and say, hey, this is an unreachable statement. However, you can still run it, and guess what happens? The program runs, there's an error because it's unreachable. All right, so let's test the scenario. The way we do this is to evaluate, as long as this is true, this statement will run. In order to get it to stop, this statement has to equal false. So one way we could do that is we could, for our own benefit, let's just say what I is. And this will not, will not run forever. And so we're going to say I++. I++ is an increment operator. It allows it to, on every iteration it comes through the loop, it's going to basically say I plus its current value plus 1. All right, so let's see what happens when we run it. So when we run this again, I++, we see that it gets up to 9 and it stops, because once it reaches the value 10, it's no longer, right? So here's the other thing that happened here. We have I before the I++. So we're going to type in before. And now we're going to copy this statement and paste it here so you can see what I is after. So this is before incrementing. This is after incrementing. Save it. Run it again. And we can see what the value was before and after. So we start up here at before. I equals 0. And then after incrementing, it equals 1. And then it comes back into the loop, and it says I equals 1. And then after incrementing, I equals 2. And so on and so forth. You can also test this by using the debugger and right-click on the little triangle there so we can see it. And we'll just put a breakpoint in here. And click debug. And now we can see, let's do this way so we have better screen visibility. So the breakpoint stopped on I, and right now it tells us over here that I equals 0. So we will step through it. I equals 0. After it, I equals 1. It comes back up. I is 1 now, but it's still less than 10. Goes through. I is 1. After the increment, I is 2. And you can see that until we get to, let's go up to 10. We're at 9. My computer froze up on me. What happened? There we go. 9. All right, we're at 9 right now. So I equals 9. Or that's what the value is in memory. It's less than 10, so it's still going to run it. Okay, now I is 10 inside the method, inside the code static curly brackets there. And now that it's 10, it's going to come up here and it's going to say, is I less than 10? Well, it isn't, right? And so at that point, it will break out of the code. And it exits the public static main void method, and it's done. Okay, so this is one way of doing it. Another way of doing this would be to say we have a scanner equals new scanner. We're going to take system.in as the parameter. We're going to say scanner, and I told y'all to do this last time because it's easier. Use delimiter, right? And so that's our delimiter, right? So we're going to start this by saying, let's see, sout. By the way, if you didn't catch that, the quick way to do that in IntelliJ is to get your keyboard not to freeze up. There we go. All right. So SOUT tab, it gives you your print line, makes it easier. I believe if you do SOUF, yep, you get the format option. So SOUT, print line. And we're going to say, please enter, let's say, C to continue. Please enter E to exit. Now, if you looked at your PowerPoint slides and if you looked at your textbook, you'll know that there are two ways to exit a loop. One of them is by using this increment operator. The other is using some type of gatekeeper parameter. So what we're doing is we're setting up a simple gatekeeper parameter here. Okay. So I'm going to say scanner next, because we're using use delimiter. That's all we have to use is next. And I'm going to pass, I'll let this introduce the value for me. This is the start stop parameter. So now what we're going to do is just simply say if C, let's see, if start stop parameter equals ignore case, the letter C, we continue. Or, better way to do this, a tricky way to do this, it's like this. If start stop parameter equals ignore case C, I think I'm going to do this again. Oh, Leo, you're here. I didn't catch you there a minute ago. Give me 1 second, class, as I update this. Omar, could you shut that door for me? Where'd you go? Okay. So I'm saying if it's C, I'm going to continue. So if it equals C, I think I'm going to do this again. If start stop parameter equals ignore case E, out, I am out of here. What do you think we should put? What keyword would just stop this? That certainly would. That would also kill the program, right? But let's say we don't want to kill the program. We just want to exit the loop. What do you think? There's a keyword that we can use. Starts with a B. There we go. IntelliJ already was ahead of you, but you know, it's all right. So while it's true, right? So let's make it more interesting. Let's put the scanner input inside of our while loop. Oh, the insanity. What are we going to do? What do you guys think is going to happen? All right, let's make a guess of the code before we run this, and you all tell me what you think is going to occur. Who would like to just maybe stand up and say, looking at the code, walking through it, this is what's going to happen? This is a good exercise, by the way. Don't be afraid. Anybody? Don't worry. Someone, come on. You can do it. You guys got this. Chris, you want to try? All right. Well, let me ask you this. What happens here at this point? The application does what? It starts, right? Right? And then the scanner says what? we tell it to start preparing to listen, right, for system.input. Okay? And then we hit the while loop. Oh, the next thing that happens, we set a variable, right? We set the variable I to 0. And then we say, while it's true, which it's always going to be true. So it means that we have to figure out some other way to end the madness. So we scanner dot use delimiter. We tell it to use the new line break character. We read these menu options, right? C to continue, E to exit. We read that input at that point. So whatever they type in. Because if they don't type in a valid input, it's going to come up again, right? So one of the ways we could do this, by the way, is system out print line. What you typed makes no sense, buddy. Try again. And to make it interesting, we'll say this was your right? Okay. We'll just run the program and see what happens. All right. Please enter C to continue, E to exit. Well, I'm just going to enter H because I think H is a fun character. What you type makes no sense, buddy. Try again. This was your first attempt. Okay, how about R? That was your second attempt. Okay, how about 6? Okay, how about C? I think I'm going to do this again. What you type makes no sense, buddy, right? So there's some question here. All right, well, what about if I type E? I'm out of here. All right, make sense? So this is another way that you can exit the code. All right, so this is the while loop. Now, you can also do loops inside of loops. You can get all kind of loopy in here, okay? You can put another while loop right inside of this. You can say while I is less than or equal to 3. I might say something like this. Sout too many tries. Sorry, Charlie. I think that was from an. You ever watching the old tuna fish commercials? Sorry, Charlie. When they would. I know this. I'm dating myself now. All right, so let's run it again. Oh, sorry, Charlie, but we need to break, right? Let's change it a little bit more here. Let's say we'll cut that right there, and we'll say if start stop parameter equals ignore case C, but we're going to use this little known value, the exclamation mark. Y'all know what this does when I use an exclamation mark? No, it doesn't make it important. It negates. Okay, so we're going to say stop again. Start parameter equals ignore case. What's the other letter? E, right? So then I'm going to paste that code in there. And we're going to copy this. and put it right inside of this if-else statement. All right, so think about what's happening here. All right, for readability, I'm going to drop that down one line. We have while equals true, scanner use delimiter, system out, enter C to continue, E to exit. We read the parameter. If it equals C, I think I'm going to do this again, right? If it equals E, I'm out of here. If it doesn't equal C or E, then what you type makes no sense. Try again. This was your blank attempt. Too many tries when it gets to what? 3. Okay. Easy flow control that you can use in your applications. All right, so we have, I'm going to just type gibberish. Whoops. Got to type down here. J, enter. Doesn't make any sense. All right, how about T? Doesn't make any sense. That was your third attempt. Was it really my third attempt? 0, 1, 2, 3. So what happened there? 0, 1, 2, 3. How many attempts really is that? Right. So if I do this again, I type 3, about 5, 6. So what's happening? What in our logic here is not working right? I bet you it's because this I is not in the right spot. Probably needs to be down here, right? Let's exit the program and try it again. Okay, so we're going to type T. This was your 0th attempt. Okay, how about R? That was your first attempt. How about Y? It's your second attempt. How about Q? It's your third attempt. G? It's never getting there. So this is where it gets interesting. This is where you use your debugger. Because you want to figure out why this value is never hitting the goal, right? So let's put a breakpoint on it. And we'll run it again. But let's change it to something a little bit easier so we don't have to keep going so many times. You guys understand what I did there, right? Okay. So we're going to debug and figure out why. So we run the debugger. Please enter a value, A. Yeah, thank you. And right now, I is less than or equal to 1. Okay, so we'll skip on out of that one. And hit exit. Oh, because I clicked the exit. Don't pay any attention to this guy over here. All right, so we'll try it again. D. All right. Prompts me for the value. Where is it at? Console, there it is. D again. Now it's 1. Okay. I think I know the issue. S. So now that is that. And what just happened? What do you think happened to my logic? All right. So while I is less than 1, it really shouldn't be a while statement, should it? This is me messing up. It should be an if statement. Because you notice what was happening when it was a while, I was telling it to break out of just this loop, right? And so it was containing the break. It wasn't breaking out of all the loops. So let's make it an if now and try this again. Okay, so we'll do S, and it exited out. All right. I am failing because of my own logic here. So let's we're going to put that aside for a moment. Is that okay? All right. So this is a while loop. All right. So I'm going to create another one for you. And we're going to call this the do while loop. Does anyone know the difference between a while loop and a do while loop? You do? While. All right. In the while loop, you're evaluating as long as the true statement is at the top, you do it. Right? And the first time the true statement is not true, then it exits. Whereas if it's a do statement, you do it no matter what until you get to the bottom where the while is at. So for example, we'll type do, curly bracket, while true. Make sense? So now you're going to do it. Let's say here, int I equals 1. We're going to say I is less than 11. And my number at this iteration is I, and I plus, plus plus. If we run that, so now it does the logic inside of the static code block, inside of the code block here, until the criteria is false. Whereas the while, putting it at the top, it gives you the effect of controlling the state. So you could have it where it runs always one time with the do while loop. Whereas with the while loop, there's always the possibility that it may not even run one time if your parameter is not true. Okay? Does that make sense? Now to illustrate, let's say this is false. Will it run? What do you think? Well, let's see. It runs one time because the do while loop always says it'll run that code block one time no matter what the value is down here. If you do it the opposite way, where while is false, system out print line, I'm going to use a different letter here for so we can see it. Whereas if we do it this way, it will not run because the while catches it right at the beginning. To validate it, I'll show you what happens. Well, if we correct our bugs. All right, do that again. And excuse me while I befuddle the code here and make mistakes. All right. This won't run as well because it's an unreachable code block. You guys see that? This won't ever happen. But if we do this, Boolean run equals true, and we make this run, we make this run, but down here we say run equals false. Now we give it the opportunity to compile and test the logic of turning on and off switch, so to speak, right? So we'll run that. It'll run. Before, when it had an implicit false inside of it, the compiler says this won't run and we're not going to let it run. But where there's an opportunity for the value to be set, then it'll let it be, it'll let it do it, it'll let it happen. Now you can make this a little bit even more interesting, and you could say if I equals 2, run equals false. So now you've set the value based on the logic of the counter. And this is a very popular way of handling something. I only want it to run 2 times and do this scenario before it allows some other action to kick off. Maybe it's a database operation. Maybe it's whatever the reason might be. So you run it again, and I equals 0. So why didn't it? Let's see here. Oh, because I plus plus. So you need to make this number bigger. Like yeah, let's do 20. That'd be a big number. Run it again. There you go. Did you see what happened? We'll do it like this. J I. So if I equals 20, run equals false. Yep. That makes sense, right? Because it's going to do this loop until I sets the run to false. And so when it finally sets it to false, then it says while run is true, and run is no longer true, so it stops. And here, run can never run. because it's always false. However, if we negate it, you always heard your English teacher say things like, don't never do that. No, it's a double negative. And what happens when you get a double negative? It becomes a positive. All right, so now what's going to happen when we run this? It's going to run this first part, right? And it's going to change run to false. It'll exit the loop, and then it'll come down here and it'll say, while this is true, which it's a double negative now, it's true. Make sense? So you can flip a false to a true by putting the exclamation in front of it, right? All right, so let's run it just so you can see what happens. And I think this is an infinite loop. You know why it's infinite? There's no break. So I kill that. Oh, it's going to make me do it that way. All right. So then how do we control this logic? Say we only want this to run maybe 3 times. What do we say? If what? I? Well, do we want it? We want I or we want J? J equals what? Huh? 3? Okay. And what can we do? We can use the break. Yeah. Uh-huh. It's a good catch. Very good catch. Okay, so let's say we want to flip the scenario where it's false. So what could we do? We could say run equals true. Now I know that's messing with your head, right? Because of this bang that's right here, it's going to flip the Boolean value. Has anyone ever been in a house where there's a switch on this wall that turns the light on, there's a switch on the other wall, and then you notice that one says off, but it's really on, and you're like, well, this is the same thing. All right? It's the same thing. You guys are like, oh, I hate that. Drives me batty. All right, well, it does me too. Especially when my kids are on the other side of the room messing with me. I'm like, what's going on? Yeah. All right. Did it already run? It did, didn't it? Because here's J is 1, it's 2, and then it set the value to true, which up here was setting it to false. Okay. That's using the incrementer, by the way. Just as there is an incrementer, there's also something called a... Very good. You've been reading. Sorry, I don't mean to embarrass you, Mike, but you have a good name, by the way. Yeah. All right, so Mike is right. There is a decrementer. How do you use a decrementer? So if I'm going to use an incrementer, it's... I'm not telling you you're vampires. If I'm using an incrementer, it's... I mean, a decrementer, it's... Yeah, decreases by 1, right? All right, so let's test the scenario. Instead of making this... Well, let's leave I alone, because now I is going to reach 20. But let's take this out over here, and we'll make this I again, and we'll change this to I. But instead, we're going to say minus minus. So now, if I equals 3, we're going to flip the flag, and we're going to put a system out print line just so we can see it, right? Aha. That's not caps, is it? There we go. Aha. So we'll see it down here in the code. So what we're expecting is I to go from 1 up to 19, right? because it'll never reach 20. If it does reach 20, run equals false, and then it stops. I mean, it'll reach 20 here, but it'll never print it out, right? Because the system out print line is before the incrementer. You see that? Whereas if I just did this, it might make more sense in its readability. Down here, it only came to 19 because it was reversed, right? So now we've changed it. We put the incrementer up top. We're going to say system out print line. We're going to reverse it as well. All right, are you ready? We're going to run it, and there it went. It got down to 3. So it went all the way up to 20 right here. It set the false. It stopped that loop. It continued its code execution to the next loop. It was a double negative, so it's true. It started the decrement. So 20, 19, and it got all the way down until I equaled 3, and it said, aha, here you go. And then it exited. All right, so that is some examples of the while loop. Now, there's other ways you can do this. There's things called, let's do it right here, be easier. We have I equals plus 1. That's fun, right? Yeah. Coders get tired of typing, and so they come up with these different ways of adding values. So if they don't want it just to be incremented by 1, they can say, well, my incrementer now is 2. And so now if we come down here and we say system out print line, I is, what? Stop that. I typed something wrong. I is that. No, I is that. Okay, so if we run it, it should say I is 5 at the end. Maybe not. Well, what do you think I did wrong? Oh, no, I put it inside my while loop. So it's an infinite problem. Oh, this is good, though, because where you do this type of logic is important. You always have to think about the variables and what they mean and track it around. So sometimes it's really good to blow up the code so you can see it. IntelliJ also gives this feature where you can collapse code. Sometimes that makes it easier. All right, so we'll run it again. Oh, I got to expand my run window. Where'd it go? There it is. So it went to 3, and then now I equals plus 2. Well, that's interesting. Right? So these are all different ways of dealing with while loops and do while loops. Okay. There's one more loop I'm going to show you, and then we're going to jump into last week's homework. And this is the for loop. And there are some flavors of the for loop that you'll get into, I think it's next week, with arrays and collections. And those are very, very important reasons to have looping mechanisms. You guys know what a collection is or what an array is by any chance? It's like a list, yeah. Yeah. An array is you probably, if you were doing any type of trigonometry, or they may have talked about arrays in that area. An array is basically telling the computer memory, I'm going to store this type of data this many times and reserve that number of places. That's what it says in physical memory. And so then when you go to address that group area of memory, it just steps through it. Bam, 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 all the way down through it to your last array item. When you get into more complex things in memory, like lists and collections in Java, they're really all still based at the base level, an array, but they give you well, I'm getting way ahead of ourselves because that's next week, but they give you a lot more cool things you can do with it. All right, so let's look at the other type of loop, which is the for loop. All right, and to make this interesting, I'm just going to go ahead and create an array for you. Spell it right. Create a string array called names equals new string, and I'm going to initialize the array. You always have to initialize your arrays. You can't leave them uninitialized. So I'm going to say 5. And now I'm going to come into my for loop. And there's two ways we can initialize our for loop. We can set the initialization variable inside, or we can set it outside. I'm going to set it outside just for simplicity right now. So I'm going to say I plus plus I is less than or equal to 10. I did it backwards. Hang on. I is less than or equal to. There you go. So we're going to access our names array. I'm going to put an I on it, and I'm going to give a value of name plus I. So that when I do a system out print line and I say names dot length, let's make it more interesting. Names dot, there's a max of 10 names, so I'm going to call for parameter number 8 and display it. All right. Mathematically, can someone tell me what's going to be at array position number 8? You're hoping you're right, right? Oh no, index out of bounds. What do we do wrong? I think I did it wrong. Let's debug it. The debugger is your friend, by the way. All right, so and we're going to say that I of 0. Oh, what do you think happened here? Index out of bounds is an error that's thrown when the array, I try to insert something into a position in memory that doesn't exist. Yeah, so we need to change this, don't we? Let's change this to 4. All right. Close that. We'll run it again. This will still throw an error though, by the way. Right? So we'll do that. Run it again. That makes sense? Now, we will change this back to that, and we'll do 8 to test our very first scenario. We're going to run the for loop code, and 8 is 8. Right? Now the reason is you were right, okay? But what we're saying is if we now did something like this, system out print line names at position 0, you're going to find out that this is either going to be empty or it'll throw a null pointer exception. It's 0. So it would have been 7, but array syntax starting at 0. Okay, so this is your for loop. Okay, the other way you can set up your for loop is like that. Int I equals 0, whatever, right? These are your basic looping parameters for iterating through collections and arrays and doing flow control and so forth.